Hello everyone, welcome to your lecture on BIOS, CMOS and firmware. And in this lecture, we shall be looking at the following objectives. So the very first objective for this lecture is that we shall understand BIOS, CMOS and firmware. That is, we'll explain the motherboard's firmware known as BIOS. Moreover, we'll describe the relationship between CMOS and BIOS. We'll also look at the configuration of the system BIOS, that is, demonstrate how to access the BIOS and modify settings, for example, the RAM, processor, and video settings. Another objective for this lecture is that we will also go and dwell on power on self-test and error reporting. That is, we'll describe the post, power on, self-test, post, and audible and visible errors that post reports. And finally, we will have a look at BIOS updates and learn how to upgrade the BIOS through flashing. What is a BIOS? BIOS, the long form for the abbreviation BIOS, is basic input and output system. BIOS is a firmware that identifies connected system devices such as the CPU, the RAM, the keyboard, the mouse, CD-ROM, display, etc. The BIOS tests system devices through the power on self-test, also abbreviated as POST, and it initializes the system devices. Where is BIOS found? Firmware. Firmware is basically a software that comes embedded in its own memory chip. There are two types of memory used in BIOS firmware. We have EEPROM. So EEPROM is electronic erasable programmable read-only memory. And we have EPROM. EPROM is erasable programmable read-only memory. Now EPROM is basically they are used in older PCs, and it could be erased by the exposure of ultraviolet light. Now also, EPROM is also known as flashing the BIOS. Motherboard is set up to initialize its operations using BIOS. Let's have a look at the illustration in the slide. So if you look at the designated number 1, now that's the DIP type socket BIOS chip. If you look at 2, that is the PLCC type socketed BIOS chip. If we have a look at 3, that is the surface mounted BIOS chip, and 4 is the CMOS battery. Now commonplace, where sometimes we see that CMOS batteries, they go bad, is probably when your system is not able to keep track of the time. That means your time and the date continuously keeps on changing. That's where you know that your computer's CMOS battery has gone bad and needs a replacement. What is CMOS? CMOS stands for complementary metal oxide semiconductor. It is a type of a random access memory. Memory can be lost without a power. Onboard battery keeps this functional. CMOS stores settings used by BIOS. Settings include boot sequences, that is a hard drive parameters, BIOS and CMOS access password. These options are passed to the BIOS soon after the power is turned on. Settings can be changed by using the CMOS editor. BIOS settings and screens. Common methods to access the BIOS or the CMOS editor during boot up is by pressing the escape, the delete, the F1, F2, F10, or the Control plus Alt plus a combination of keys to actually go around editing the setting of BIOS during boot up. Most system splash screens provide information on which key to press. Now, what it simply means is that while your computer is at its startup, screen that's called a splash screen. That's where it will say either somewhere at the bottom, press an individual type of key to edit settings. Another way you could actually go around looking at which keys are used for editing the boot system is, or the BIOS, is when you can always go and consult the motherboard manual. Alteratable BIOS settings, sampling of more frequently used options. In other words, what are some of the things that you can alter in the BIOS settings? Now, precisely, we could enter the boot sequence. That is, if you would like to boot your device from the hard drive, the CD-ROM, or the USB. You can end up making memory configuration. You can also alter the CPU clock and frequency, overclocking, or allowing your computer to run in a turbo mode. CPU memory cache, hardware monitor, that is to get the status of fans in case, onboard audio or modem or network configurations. You can also go on altering integrated peripherals. The PS2 mouse disable if you're using a USB mouse, USB legacy for non-Windows USB keyboard, parallel or serial ports. Moreover, we can also go around altering the BIOS in terms of USB options for 2.0 and 3.0, keyboard options, plug and play operating systems, primary VGA BIOS, AGP card speed, serial and parallel ports again, shadowing for video BIOS, boot time diagnostics, power management, virtualization, BIOS password, or SATA or PATA drives. Most preferable choices, BIOS auto configuration, most preferable choices versus the manual setup. There are three options. One is you can stick to the BIOS defaults, that is the original BIOS settings that comes with a computer system, or you can set up defaults by optimizing the settings, or you can get your BIOS to run in a turbo mode, that is engages overclocking when the CPU is not under stress. On the slide, you would be able to see the illustration of what you will see when you're trying to configure the BIOS settings. Moreover, do have a look at the BIOS information, that is the what version of BIOS you're using, and the amount of memory or RAM in the computer system. Moreover, the type of processor that your computer system currently has. This is where, on this particular screen, this is where you can set up your boot sequence. That means where do you want your computer to boot from the CD drive. If you would insert in a USB flash drive, you would be able to boot your computer from the USB flash drive. Or if you have an external hard drive, you can even get that selected. Integrated peripherals. What are integrated peripherals? Functions that used to be optional but now are considered mandatory. So integrated peripherals include your onboard video cards, your onboard audio cards, your onboard network card, your HDMI ports, USB ports, and your external SATA drive ports. Advanced power management, advanced configuration power interface, ACPI. It offers less power consumption when enabled. 6 standard settings include SO or S0, means no power management is in effect. Input, CPU, memory, and hard drive are running. S1 or pause, that means pause stands for power on standby. CPU is off, memory is being refreshed. Now also the PSU is on and the hard drive is off. S3 or STR, STR stands for suspend to RAM. Microsoft calls this as standby, and the PCU is off, and the PSU, sorry, is off, and RAM is refreshed. Now, S0, S2, S4, and S5 are commonly not used. Note S4 is hibernate and RAM is saved to the disk. To control power management, this can also be configured in the BIOS settings under the CMOS setup utility. In it, you'll have the AC back function. This is where it can be controlled. Enabling virtualization. Virtualization allows a computer to reserve a certain amount of memory, and it builds a software that can be used as a computer within a computer system. When a SVM support is enabled in a computer system while setting up a BIOS under the BIOS utility, what happens is that you will end up enabling the virtualization of your computer system. CPU system clock and overclocking considerations. CPU speed is set as a multiplier of the clock frequency. No adjustments are needed unless overclocking is employed. Should you overclock? Better to set BIOS to turbo or extreme. These allow temporary overclocking in unused circumstances. Example, gaming. Prolonged overclocking means there is a need for a bigger fan or cooling apparatus in your computer's system unit. Moreover, a better power supply is needed. PSU, by the way, stands for power supply unit. Understanding BIOS error codes. Power on self-test or post. Codes for RAM, hard drive, and CPU failure. Memory, keyboard, and graphic cards are checked in the post tests. Problems can also be identified by beep codes and on-screen error codes. Beep codes denotes the beep sounds, whereby the on-screen error codes displays a text telling that there's an error or a hexadecimal code. Having a successful BIOS upgrade. When do you need a BIOS upgrade? Usually, you don't need a BIOS upgrade unless if it's broken or if it cannot be fixed. Issues that sometimes require a BIOS upgrade for the system to work properly are when you have a new hardware, such as a large SATA and a PATA or IDE hard drives, and different types of removable storage devices, or you need faster central processing units, or you have a new operating system and features, and when you want to set up new BIOS options. So before you do a BIOS upgrade, ensure to back up all important data. Record BIOS settings or take a digital picture of them. By taking a digital picture, you will be able to identify the current version of the BIOS software and identify the exact make or model of your motherboard. Moreover, download the BIOS update software. Most vendors provide an .exe file that requires minimal effort. Highly recommended that the CPU is plugged into the UPS. Power interruption during a BIOS upgrade may make the entire motherboard unusable. When things go wrong, some newer motherboards have two BIOS chips. So reboot using the alternate BIOS chip if the new BIOS upgrade fails rather. Check for flash or write protect jumper. Reset the flash recovery jumper. Video may not work during this process. Listen for beeps. Reset jumper to normal. Obtain a new flash chip from the motherboard manufacturer if something goes wrong while you're trying to upgrade your BIOS system. Summary. Understand BIOS, CMOS, and firmware. What we have done in the entire lecture is that we have explained the motherboard's firmware, known as the BIOS. We have described the relationship between the CMOS and the BIOS. Moreover, we have configured or learned about the configuration of the system BIOS. That is, how would you go around modifying settings, for example, the RAM, the processor, and video settings. We've also learned about post-test and reporting or error reporting. Now, with the post-tests, we would be able to see if all the hardware in the computer system, if it's working correctly or not. Moreover, errors are reported in errors reported while doing or while loading up your BIOS system may be given in terms of text, or it may be given in terms of hexadecimal codes. BIOS updates. Well, we have also learned about BIOS updates in the lecture. Now, we have learned how to do BIOS update through the process known as flashing. So this finishes the first part of your lecture. The second part of your lecture is on random access memory, and we will go over that as well. As learned in the previous lectures, random access memory is the temporary holding memory of a computer system. So in this lecture, we will learn about the basics of RAM. That is, we will describe what RAM does, how does it work, and how it relates to the system. We'll also look at the RAM types, the different types of the RAM, including SDRAM, DDR, DDR2, and RAM bus. We'll also look at operational characteristics, whereby we'll describe the features of memory modules and the type of memory like ECC, EDO, registered, and unbuffered. We'll also look at how one would go around installing memory modules, and we'll demonstrate the installation of SIMs and DIMMs properly. Moreover, the lecture will also include troubleshooting memory, that is, describe issues with RAM due to incompatible memory speeds and type. And finally, we'll look at preventative maintenance for memory, that is, describe measures taken to keep memory modules clean and protected. Random access memory. Random access means that the memory addresses are dynamically allocated rather. Different from ROM, in which memory addresses are pre-assigned to specifically coded functions. What role does RAM play? RAM provides CPU with data to process. It also provides keyboard entries, which are sent to the RAM address, hard drive programs which are sent to the RAM address, and network data or web pages are sent to the RAM addresses. RAM is faster than other storage, such as hard drives and USB memory. Reasoning why? Because it has less moving parts. Installing more RAM is often the easiest way to improve system performance without investing into a new system. RAM specifications to know before you go around buying them. Module type. Module type generally refers to the number of pins and placement. So the number of pins RAMs generally have is 240, 184, and 168 in the different types of RAMs. The number of RAM slots available for modules. So if you have more than one RAM slots, then you can go around installing another RAM into your computer system. However, some computer systems only have one RAM slots, which may not permit you to insert multiple RAMs. Chip type. Common chip types are SDRAM, DDR, and RDRAM. Speed, it needs to match up it needs to match up as multiple of motherboard front side bus speed. It is measured in terms of nanoseconds or in terms of throughput. Error checking, optional, purchase with database servers. And also you'll go around checking the number of modules needed by bank and dual channel or triple channel configurations. The important things, however, that needs to be taken into account is the module type, the chip type, and the speed. Types of RAM. There are generally few types of RAM which are continuously being used in the computer systems these days. First one is SRAM. So SRAM stands for Static Random Access Memory, also known as L1, L2, and L3 cache memory. Does not require a memory refresh. Used with CPU to store frequently accessed data routines. It's fast, but it's expensive. Now, it's not generally upgradable. The next type of RAM is SDRAM, which stands for Synchronous Dynamic Random Access Memory. SDRAM basically have been used in PCs before 2000 and are still commonly being used. Rated by bus speed, that is 266 megahertz per second bus speed, and it uses PC266 SDRAM. DDR stands for double data rate. DDR basically is rated at a through speed in megabits per second. DDR2 double data rate enhanced. It is basically twice the speed of a DDR. And finally, RAM bus. This is a type of RAM which is not commonly used these days. The illustrations in the slide represents the different type of RAMs. So right on the very top, we have a DDR2 or a DDR2 RAM. The second one that you have is a DDR. The third one is you have a plain SDRAM. Then you have a SIM, you have a SIP, and you have a SIM again. Now do notice that each of those different types of RAMs have different number of pins. Now this becomes very much particular when you are trying to upgrade or install a new RAM in your computer system. You would need to ensure what type of RAM you want to actually feed in, and moreover the number of pins that your computer's motherboard can generally accommodate. These are some additional informations on the different types of RAM, and it is suggested that students should go over it upon some free time. Operational characteristics. Memory modules are classified in various ways. There is the amount of memory in bits found on the module, the difference between parity and non-parity memory, the difference between ECC, ECC stands for error correction code, and non-ECC memory, the difference between registered and unbuffered memory, the difference between single-sided and double-sided memory. The following set of slides with these operational characteristics are described. Memory module characteristics. Single inline memory module or SIM. Single row of 30 or 72 edge connectors. Single refers to both sides of the module having the same pinout. Single inline pin package or SIP. Variation on the 30-pin SIM. Dual inline memory module or DIMM. This particular memory module has 168 pins. It also comes in 184 and 240 pin versions. Now, dual refers to each side of the module having a different pinout. We have small outline DIMM. It is a compact version of the standard DIMM module for use in notebook computers. And finally, we have RAMBus RDRAM module or RIM, a memory module using direct RAMBus memory or RDRAM chips. Operational characteristics. Memory module width. 1 bit is equals to 1 byte. The basics of binary. Memory is sold as measured in bytes, megabytes, nowadays also in gigabytes or in terabytes. Memory width refers to the 32-bit or the 64-bit part, usually matches processor or motherboard part. A memory module is the same as a memory bank. A bank of memory is one module installed in a single memory slot. Slots must be compatible with the memory module. 72-pin slots versus 168 or 184-pin slots. Multiple banks usually require meshed pairs of memory modules. Operational characteristics. First of all, we'll have a look at parity and non-parity memory. Now, parity and non-parity memory, they do error checking, and the error checking memory costs more. Small performances decrease in terms of parity and non-parity memory. Now, there are two types. You have parity checking. Now, parity checking, it is the use of a parity bit to compute a value that must match another value to validate a data set. ECC or error correcting code is another type of parity and non-parity memory. So what it does, the memory that both finds and corrects errors. Now, ECC is typically employed on servers. Registered buffer versus unbuffered. So buffered memory or registered memory enables systems stability when large memory banks are used. Installing memory modules. Pre-install precaution, importance of ESD protection. Memory can be damaged and the damage may not show up for weeks. ESD strap must be attached to a ground or a bare metal portion of the chassis. Hold memory modules by the side edges without touching either the pins or the memory chips. Therefore, check to see if the locking tabs are swiveled out to open position. Line up the module to accommodate the notch that ensures that the module is being inserted in the right direction. Push module straight down into position. A slide rocking motion from end to end helps seat stubborn modules into the slot. Engaging the locks requires extra firmness to force the locks to close into the notches of the sides of the module. Now, what we have described in the previous slide is now being represented in the illustration. So these are the slots. The channel A, the blue one, this is where it should be installed in pairs, and channel B slots are used. Now you would see that in the illustration, a RAM is attempted to be installed. The first image, the image on the top, you would be able to see that the RAM has not been properly engaged. Try to have a look at these portion, whereby you see that these are still quite above the slot. And if you look at in the bottom picture, you will see that the RAM has not been engaged and the silver chips or the pins, that as we normally call it as, have been now inserted in the slot accurately. After that, once you have pressed in the RAM in the slot, what you need to do is you'll need to lock your RAMs using the clips on the left and the right hand sides of the RAM. Troubleshooting memory. Some common sources of problem when dealing with RAM installation or upgrades. You have an incompatible module or an incompatible RAM. Moreover, your RAM may be overclocking or overheating, allowing it not to work properly. Incompatible metals in slots and on pins. What it simply means is that sometimes you may have corrosions on the slots, and it needs to be cleaned periodically. You have mismatched RAM speeds. Now, remember, RAM speeds are generally measured in nanoseconds. Lower numbers means faster access time. Newer systems generally adjust to slower modules. Determining if cache RAM has a memory problem. Cache RAM holds a copy of the information in main memory. Errors in cache RAM can appear to be errors in system RAM. Procedures to determine if cache RAM is a cause of a memory problem. The first thing you can do is disable L2 cache first. If the memory problem goes away, determine where L2 cache is located. That is in the processor or the motherboard. If the motherboard uses removable cache module, replace it. If the motherboard uses the non-removable cache chips, replace the motherboard. If L2 cache is built into the processor, replace the processor. If the system runs normally, the replacement is successful. If the problem persists after replacing the component containing cache RAM, return the original components to the system. The second option is disable L1 cache. If the system runs normally, replace the CPU and retest. If the system runs normally after replacement, the L1 cache was faulty. Still on troubleshooting memory. Now RAM sizing errors at boot up. Note that the memory count reached on screen when the memory error is detected. Check the motherboard documentation to see if modules must be installed first. Change one module at a time, starting with the one you think is defective until the error goes away. Disable cache RAM in the BIOS setup when testing memory. So these are some of the things that you could do to ensure that your RAM is not a problem when you are trying to use a computer system, or when you also determine that there are issues with the RAM. So these are some of the troubleshooting features that you could take up with. Preventive maintenance for memory. Now, these are some of the things that you need to ensure that you do not end up causing your RAM to go bad. Now, keep the surfaces of the module clean. Use compressed air or a data-rated vacuum cleaner to remove dust. Use the recommended voltage level for the memory installed if your system BIOS setup permits voltage adjustments. Install additional case fans over or behind the location of the memory modules to pull hot air out of the system. Keep air intake vents in the front of the system clean, and moreover, replace any defective cooling fans. What have we learned so far? What we have learned is the kind of memory that would be useful to verify data integrity. Moreover, we also looked at how many memory modules are required for a CPU with a 64-bit bus width. Also, we looked at what kind of memory module is typically used in L1 and L2 cache and does not require constant refresh. And finally, in what speed standard is memory used? Summary. In the summary section, we actually had a look at RAM, what it does, how it works, and how it relates to the system. We looked at the types of the RAMs that are available, including SDRAM, DDR, DDR2, RAM bus. We also looked at the features of the memory modules and the types of memory like ECC, EDU, registered, and unbuffered. We went around demonstrating the installation of SIMs and DIMMs properly. Moreover, we described issues with RAM due to incompatible memory speeds and types. And finally, we had a look at some of the measures that can be taken up to carefully clean and protect your memory modules. So this finishes up the lectures for the week. Thank you for listening, everyone. Goodbye.